Now, we've already looked at solving type 1 equations. And type 1 equations really involve one real step, right? One type of movement. So we were either going to move something across the equal sign once, right? Whether it be divide or multiply or add or subtract. Type 2 equations, and think of the number 1 as, well, type 1 involved one movement. So type 2 will involve at least two movements. Okay? So again, we're solving for the variable. So we're solving for x. So type 2 equations will require you to do two opposite or inverse operations to solve for the unknown, which is what we called our variable. So remember what we said? We separate from our equal sign all our unknown values on one side and our known values on the other. So we want to collect everything that's unknown and everything that is known on the other side and then use it to solve or simplify and solve for whatever the letter that we're using. Right? So let's look at a few things now. When dealing with this, you might have a variation. You might have some addition, subtraction, some multiplication altogether, division, right? All in one. My advice to you is to do the following. Always do the addition or subtraction parts first. Okay? So do all the addition parts, all the subtraction. So if you've got addition and you need to move something that is positive across the equal sign to becoming negative, do that first. If anything is divided on one side and you need to move it, do those last. Okay? So then do the inverse operations of multiplication or division last, very last. Okay? So let's look at a sample problem. So type 2 sample problem. So the question says solve for the following. Okay? So what are we going to do? So take a moment, and what I want you to do is I want you to pretty much isolate your unknowns and your knowns. So first, label your knowns, and then label your unknowns. And pretty much arrange them on the appropriate sides. Let's look at, let's see if yours matched up with mine. So we've got 4x. 4x is an unknown value. We don't know what the value is because there's a variable. This positive 5 is a known value. We know what it's worth. This 33 is also a known value. So let's collect our unknowns. So 4x, does it stay on this left side of the equal sign? Yes, it does. Because it's on the right, on the correct side. Positive 5, should it stay on this side of the equal sign? No, because it's a known. We said we're going to put knowns onto the right side. So when we move it across the equal sign, positive 5 becomes negative 5. Okay. Then this positive 33 is a known value. It's on the correct side. So 33 as it itself just means that it's positive 33. Now, we can do one of two things. We can solve this, right? Or if I want, I could have kept the 33. I can keep whatever doesn't need to stay. And then I could have brought this positive 5 over and it became negative 5. So it doesn't really matter. I'm going to still get the same value. This way, I kept what stayed. This way, I ended up moving in the order that I saw them. So you can do it either way you wish. So let's just solve it. Maybe this bottom way was a little bit simpler. So we have 4x is equal to 33 minus 5 is going to give us 28. If this was a type 1 answer, or sorry, a type 1 equation, we would have been solving, it would have been solved by now. But there's one more step, right? So the step is to find out what is the value of x. We don't want the 4 in front of it. 4x is equal to 28, but we want only x. So remember what we said in the type 1 equations. To find the value of x, divide this by whatever number is in front of x. So the number that is in front of x is a 4. So divide it by 4, because the 4's divide out to leave me with just x. But remember in math, whatever I do to one side of the equal sign, I must do to the other. So 28 divided by 4 is equal to 7. So that is my value of x. So I can go in and substitute into the equation. So I have 4x plus 5 equals 33. So, what I'm going to do is, instead of x, right, I am going to put, what is the value of x? The value of x, as we said here, is 7. Plus 5 equals 33. So, according to bedmass rules, we do multiplication first. So 28 plus 5 equals 33. 28 plus 5 is equal to 33. So the left side is equal to the right side. So we know for a fact that x is, in fact, equal to 7. Now, let's solve for the following sample problem. X over 3 plus 4 equals 10. So now, here's the thing. Remember what we said at the beginning of this lesson? We said we want to do the addition subtraction first. Okay? So, but before that, we want to separate the left side from the right side. Okay? So what we're going to do, as we said, we're going to put our unknowns on this side. We're going to put our knowns on that side, right? So, x over 3, this is considered an unknown value, right? Because we've got x. This positive 4 is a known value. This 10 is also a known value. So now, what we're going to do is we're going to do something a little different than we did solving the other ones. What we're going to do is, let's keep, right, on their respective sides, what doesn't stay, or what should stay. So this x over 3 doesn't change. It's on the correct side. We look at the other one, this positive 4, let's not move this yet. Let's look across the equal sign. This 10 is a known, so it's on the correct side. So we keep that there. So now what we're going to do is just move what doesn't belong there. This positive 4 is on the unknown sign. We want to put it on the known side, because look at how we've labeled it. We've labeled it with K. So when we move this positive 4 to the opposite side of the equal sign, it goes from being a positive 4 to a negative 4. So now we're left with x over 3 equals 10 minus 4, which is 6. But again, we want to get rid of, we want to isolate for x. So because the number 3 is in the denominator, right, we are dividing x with 3. So for us to move 3 across the equal sign, it means we are going to multiply. So x is isolated, 6 becomes multiplied by 3. Because we're multiplying it by 3 on this side, because we are dividing this side by 3. So remember, we always do the opposite whenever we move something across the equal sign. So x is equal to 6 times 3, therefore x is equal to 18. Now we can go in and do a check. So instead of x over 3 plus 4 equals 10, what did we say that x was equal to? We said that x was actually equal to 18. So, according to bedmass rules, we're going to do division first. So 18 divided by 3 is 6, plus 4 equals 10. 6 plus 4 equals 10. 10 is equal to 10. So the left side is equal to the right side. So we know for a fact that x is equal to 18. Now, here's where things get a little bit tricky. Solving with fractions. One of the steps that I like to do is I like to get rid of the fraction first. Okay? So, because all the denominators are different, we cannot add or subtract by the same fraction. So, we cannot add our numerators. Sorry, we cannot add our numerators because our denominators aren't the same. So what we want to do is find the lowest common denominator. So what number do what is the smallest number that each and every single one of these denominators can go into evenly? And that number is 12. So what we can do is we're going to multiply. Right, we're going to put brackets around each one of the fractions. And we're going to multiply each one by 12. Now watch what I do now with this. So 12 I'm going to divide each one of these 12s with the denominator of that fraction. So 12 divided by 2 is going to leave me with 6. With 6. So all I'm left with, here is 6 times 1 times x, which is equal to 6x. So notice now I have no denominator. Now we've got a positive here, so plus. Now we're going to do the same thing, but now 12, we're going to divide it with the 4 here. So 12 divided by 4 is going to give me 3. 3 times the 3 is going to give me 9. We do the same thing with this last one, so it's equal to 12 divided by this 3 will give me 4. 4 multiplied with my denominator is equal to 8. So I can now look at this and go, oh, there are no more fractions in my question. So now my equation looks no different to all my other problems that I've done. Now, we're going to do now the same thing, because the question says solve for x. Right? So what we're going to do is, well, this is our unknown. Right? 6x. Positive 9 is a known value. This 8 is also a known value. So when we move things, well, we're going to keep unknowns on this side of the equal sign. We're going to put known values on this side of the equal sign. So here's our equal sign. So unknowns are going to be on our left side. So 6x doesn't move. This 8 also doesn't move. The only thing that moves is this positive 9. We want it on this side. So if it's positive on the left side, when we move it to the right side, it becomes negative. So now I'm left with 6x is equal to 8 minus 9. So 6x is equal to 8 minus 9, which is negative 1. So now, I'm just going to rewrite this all up here so we can, so I have room, right? I don't have any room down here. So I want to find out what is the value of my x. So remember what we said? We're going to divide this by the number that is in front of x. And what is the number in front of x? The number is 6. So we're going to divide it by 6. So remember what we said? 6 divided by 6 is going to leave me with what? Exactly what I need to be left with. Just the x. But what I do on this side, I must do to this side. So x is equal to negative 1 over 6. Okay. We can go about doing the check. It's just going to get a little bit messy. But leave that as up to you as a viewer to do the check when dealing with these fractions. So the answer to this question is x is equal to negative 1 over 6.